Review topic 3 will help you with density and temperature. Here you see some examples of densities of different liquids. And here you see kind of a temperature scale depicting the relationship between Fahrenheit, Celsius, and Kelvin. We're only going to be focusing on Celsius and Kelvin in our class. Remember that if you are less dense, you are going to be able to float. So the more dense honey is sitting here at the bottom. So density is just how much mass you have for a given volume of a substance. Volumes can be measured in a few ways. If it is a geometric shape, you could use a traditional volume calculation to get that. I think you have one of those on your assignment, length times width times height. Or you can measure it with a graduated cylinder for something that doesn't have a set shape. It is a physical property, so you can use this to help to identify substances, but it will vary depending on the temperature because volume can change based on your temperature. And so your equation's density equals heart, or density equals mass over volume. Some of you have seen this before, I suspect. Just showing you how you can algebraically rearrange the density equation to solve for d, m, or v. Temperature is representing the random motions of your molecule. This is something that is measured with either a thermometer or some sort of temperature sensor. It is not the same as energy. You can't measure energy, but you can calculate it. You can calculate energy changes for a phase change or for a temperature change, or you can combine those together. But you can't just calculate energy at one point. It's got to be for a change, a transfer of heat in one direction. Something that we'll talk about a little bit more with gases is that kinetic energy is directly proportional to the Kelvin temperature. So again, you do need to know the Celsius to Kelvin equation. I went ahead and added the 0.15 in because we do know it out to that amount. I'm fine if you use 273, but I just wanted you to be aware that there are those two decimal places. So we're going to do a couple of density equations. Iron has a density of 7.87 grams per centimeters cubed. The volume of iron is measured to be 75.0 mils. What is its mass in grams? So if we're solving for m, we want to multiply density and volume together. If you look at this example, you'll see that the units of density in terms of volume are not the same as the volume that it was measured in. But a centimeter cubed and a milliliter are exactly the same. So those can be canceled out because they are equivalent. The density has 3 sig figs, the volume has 3 sig figs, so we want 3 sig figs in our answer. So we want a decimal after that 590, and then we want to use units of grams because those are what are remaining. In our second example, this is more of one that we would do in lab. We have iron pellets that are poured into a graduated cylinder that has 12.7 mils of water. The water level rose to 21.6 mils. We want to figure out what the mass is of our metal in grams. We're going to do one similar to this in on the summer assignment, but I believe you're going to find the final volume instead. You also already know the density of the iron pellets that was given to us in the first sentence. So here's a graduated cylinder. We have 12.7 mils of water in it to begin with. We're going to take our iron pellet, we're going to plop it in there, and we see that it causes the water level to rise to 21.6 mils. So if we want to find mass, we want to get density and volume. We know the density of the iron, but we need to get the volume of the iron. And we can get that by subtracting these two, because that'll take away the water that was a part and leave us just with the iron. Iron's volume can be determined by this, just like other solids, as long as it doesn't react with the water, it doesn't float on top of the water, and it is not soluble, it doesn't dissolve in the water. And all of those exceptions do not apply to iron. Iron's going to sink to the bottom, and we get that the volume of the iron metal piece that we placed in there was 8.9 mils. Since we know the density of the iron is 7.87, and we know the volume is 8.9, when we multiply those across, we see the density has 3 sig figs, the volume has 2, so we want 2 in our answer, which would give us 70 with the decimal grams. Our last example is going to involve temperature. We're going from Celsius to Kelvin. We know the average temperature in school is 25. We want to know what it is in Kelvin, so we would add 273 to 25. 25 had one decimal place. 273.15 is a precise value, and it has 2. but this one had the fewer sig figs, so we're going to go with 1. But when we add these together, the 5 would make the 1 round up to become 298.2. And if we go out to our assignment, this should help you with questions 12, 13, and 14.